Okay, so something recently dawned on me, and it's that I've never actually covered solid principles. I've done lots of other object-oriented principles, I've done design patterns and various things like that, but never actually covered solid. I have done it in like blog format, which I've sent out to my mailing list, but never on video. And so let's give it a go. Here, what we're going to do is, because of solid principles, the kind of, I'd say, misunderstood, or also they're not easy to understand because of the way that they're written. The descriptions sometimes don't make perfect sense, and so your understanding and my understanding of some solid principles might be close, but we might be sort of missing sort of fundamental understandings of what problems they are trying to solve. And that's the approach I'm going to take in these. I'm going to work backwards from the actual problems that the solid principles exist to solve, and then at the end of it what we'll do is we'll revisit the name or revisit the description and say, can we reword it? Do we understand what this actually means now? And so we'll take single responsibility as an example, and what I mean in practice is that we'll have a look at the wording, but then we'll switch our focus mainly to the problem that it's trying to solve. We'll have a look and add an example, and we'll also either include a solution or we'll have a look at a prevention. And also, just as an added bonus, we'll try and solve these or prevent these using some design patterns. So quite a lot to learn there, quite a lot of cool stuff that we're going to cover. Let's start with the single responsibility principle. So you may see two different wordings for this. The one that I've seen the most is this one: a class should have only one reason to change. And then I've seen another one which is this: a module should be responsible to one and only one actor. Neither of those is any more clearer than the other. A class should have only one reason to change its underwear, to change the world, to look in the mirror and make that change. It's really not clear, and that's why there's so much sort of ambiguity and misunderstanding between developers as to what single responsibility means. So I'm going to show you the problem it solves, and then we'll come up with a solution, a prevention or a solution, and then we'll also have a little discussion about what single responsibility does not mean, because I've seen people banned around the word single responsibility or the phrase single responsibility for scenarios which aren't actually breaches of single responsibility. Here is the example that I'm going to demonstrate with. I've created this spend tracker class. Let's go and have a look. And it kind of does what it says on the tin. It tracks a user's spending. We have a max budget property. We have a current spending property. And then most of the action takes place in this track spending method, which receives an amount. It bumps the user's current spending by that amount. And if the user's current spending then exceeds the max budget, it notifies them that their budget limit is exceeded. So there's nothing that we've seen there that would say that we're breaching single responsibility here. I think it's totally reasonable to be able to notify a user that they've exceeded a budget limit in a class which is designed to track spending. Just because a method or a class does more than one thing does not mean that they've breached the single responsibility principle. But if the class has more than one reason to change, and we'll come to that wording in a minute, then it is breaching the single responsibility principle. And ours does have more than one reason to change here, because the way that we're actually sending that notification is all handled by the actual spend tracker itself. And so here, if you see, we're using a mailer which we are injecting into a spend tracker. If for whatever reason it is decided that notifications are going to be sent by some other means, for example SMS, and I have created an SMS dispatcher, then what that means is that this class has a reason to change. If, for example, the track spending mechanism was going to use floats instead of ints, or it was going to include currency as well as an amount, then you would have another reason for this class to change. Because we are looking at two responsibilities. We're looking at the responsibility of actually handling the amount of current spending and making comparisons, but we're also handling the mechanism for sending notifications. The sin here isn't in actually sending the notification. It's actually handling all the mechanics of sending that notification. So let's go and make this change now. In fact, before we do that, I'm just going to run the tests, because this is all under test. If we go and run this, the tests are passing. However, if I go and make the changes, it means I'm going to need to go and make changes to my tests for my spend tracker class, which needn't be changed if they were isolated away in their own class with its own single responsibility of handling the notification. Okay, so let's go make the change. Here we're going to say we're not going to send it using the mailer, we're going to use the SMS dispatcher. And so down here we're saying this dispatcher dispatch. Let's go and run the tests again. So now we have broken tests for our spend tracker. Spend tracker construct argument number 1 dispatcher must be of type app SMS dispatcher. So we're already creating a break which needn't really have existed. So let me show you how we could have avoided this. Instead of actually injecting our SMS dispatcher or our mailer or whatever, what we would do is we would have a notifier object or a notifier class which does all the handling, and if anything needs to change regarding the handling of sending the message, that change takes place in the notifier. So inside of source, I'm going to create a class called notifier, and then it is here where we're going to inject the parts that we need. So for example, SMS dispatcher, and then we'll have a function called notify, so notifier notify with a string message, and then we'll say this dispatcher dispatch message. Okay, so if we go back to our spend tracker here now, all we need to, or all that the spend tracker needs to know or needs to receive is just a notifier, and then we can get rid of this notify method completely and just say this notifier notify. And then if the methodology changes for actually sending a notification, we're making the changes, or the changes are isolated to our notifier class, and nothing will actually need to change here. So let's go ahead and do that. So here we're just going to make this change to mailer. All of those changes have been handled by the notifier. If we just go over to our tests, and then here instead of mocking the mailer, what we'll do is we shall mock the notifier instead. Mockery mock notifier, and instead of the notifier expecting send mail, it's just expecting notify. Let's run the test and see how we get on. Okay, so we have a passing test. And if you remember what we said at the very beginning when we talked about what problem that we're trying to solve here, we saw God objects, tight coupling and change chains. Focusing in on change chains there, not only do we not have to make any changes to our spend tracker if we decide that we're going to change the way that notifications are sent, but also our spend tracker test is not dependent on any kind of object which is responsible for sending notifications. We're now just receiving a notifier, and so if any of that mechanism changes behind the scenes, we do not need to touch this test. This test will now run and pass forever whilst our spend tracker is handling only one responsibility. So let's wrap up. At the beginning we said that the definitions were these: a module should be responsible to one and only one actor, a class should have only one reason to change. They're still confusing definitions, however we now know what problems we're trying to solve. We've had a look at that problem and solved it ourselves. Hopefully now we both understand single responsibility principle better than what we did at the start. Let's move on. In fact, just before we wrap up on this, at the beginning I said that I'd also cover some of the things which single responsibility is not. So here are some common misconceptions. These are probably the most common ones, and they are: a class should do one job. This is false. A class should have one clear responsibility, but that can incorporate all different jobs into that. A method should only do one thing. Again, very common. Just because a method might fire off a notification as well as increment a spending amount, then that is perfectly fine. It falls within the responsibility of tracking a budget, and cohesion equals coupling. Again, just because we've injected a class, a notifier, which is going to send notifications when a particular limit is exceeded, that doesn't mean that we have some tight coupling. The notifier is a cohesive part of this unit. It's an important part of tracking spending, is letting the person know that their spending is being tracked. But we're not coupled to it, because if we need to change the way that the notification is being sent, that is all hidden away inside of the notifier class, and nothing needs to change in this spend tracker. So we can't say that we have tight coupling. So you'll hear other misconceptions and other fallacies regarding single responsibility or other misunderstandings, but these are the main ones. I think we have a good understanding of what it is and what it isn't now. Okay, so we're on to the open-closed principle. I think the wording of this one makes it a little easier to understand, a little easier to apply, but I've still seen it misinterpreted in some places. So let's have a look at the wording, and then we'll have a look at maybe an easier kind of way to think about it. So software entities, classes, modules, functions, etc. should be open for extension, but closed for modification. Now basically what that means, if you want an alternative wording, is this. Once a software module is completed, it should not be modified when adding new functionality. Instead, its behavior should be extended by adding new code rather than changing existing code. Now, one area where this gets sort of misinterpreted is in the word extension, because if you're coming from a language which uses extends as a keyword in inheritance, a lot of times people think that you should solve the problem of adding new functionality by using inheritance, and that's really not what this means. What this means is extend the capability of a class using whatever means, not necessarily restricted to inheritance. And indeed, in this one, I'm going to show you a way of extending the capability of a component without using any inheritance and without actually touching that class whatsoever. But before we look at that, let's have a look at the problems this intends to solve, and then I'll give you an example in a moment. So it avoids cascading modification, because sometimes if you make changes to one piece of code, it means you're probably going to have to make changes to other pieces of code, especially the client code, which actually use that component. And therefore it avoids bugs and downstream breaks to code which is already tested, and probably code which is already released and being used by others. So let's go and have a look at the example that I'm going to use here. I have a image class, and this is being used to render HTML images, and the problem that we're going to try and solve here is how we can actually what if we want to wrap this image inside of link tags or inside of paragraphs or inside of something else. And so a quick run through this code. The class image, it simply implements a interface called HTML element interface. Kept the design fairly loose, not even included a return type, but we're just saying we need to implement a method called HTML. I'm injecting a source so that the image has a source to reference, and then we just return an image tag including that source. So what if we wanted to wrap this in a link or a paragraph? So just to demonstrate a breach of open closed, we'd be doing something like this. If we wanted to wrap it in a link tag, ahref, would have to modify it like so, but then we are sort of breaking this, and it means that it's no longer just an image tag. So then you'd be thinking about, well, am I going to include a boolean here to say wrap it in this? Or we're already starting to make changes to the API, aren't we? And if we have to make changes to the signature, it means that's going to break, because we're not keeping in line with the actual signature, which has been sort of defined in this interface here. So making a load of breaking changes. Also think about the client code. If we're going to start changing the signature and start injecting references to wrapping this in links and things like that, it means you've got to go and find all the client code, even if you know where to find it all. What if this is part of a library that other people are using? You're introducing downstream breaks. So this is why open close exists. It's to avoid modifying code, because it's just going to cause a load of headaches to other people and make you very unpopular. So I'll let you have a think about how you would solve this problem, but have a look at this one little gotcha that I've actually added to the beginning of this image class. I've marked it as final, and this really is to just demonstrate that you can solve problems without using inheritance, and that the open-close principle is not telling you to use inheritance to solve the problem of open-closed. And so we're going to have to think about how we're going to solve this a different way than using inheritance. Now, as well as not being able to extend this, when someone marks a class as final, that's usually a clue to tell you that this class requires no modification. If you're thinking of modifying this class, you're probably doing something strange or wrong. And indeed, this image class is doing everything that we need it to do to render an image. So why would we change this? I'm going to solve this using composition. And in particular, I'm going to use a design pattern. I'm going to use the decorator pattern. And the decorator pattern is a compositional pattern which exists to solve exactly these kinds of problems. Now, the first thing to do with the decorator pattern is to define your interface. Now, by that, I don't mean create an interface, but sort of define your API for your decorators. And so the way I'm going to do this will be with an abstract class. I'll just call this HTML decorator. So we're going to decorate HTML elements by wrapping them in other HTML elements. And you'll notice that I've appended the word decorator onto this, and that is just to let other developers know that this is a decorator and we are using decorator pattern, and it'll just help them figure things out a lot quicker. Okay, we need to make this abstract. First of all, I'm going to declare my strict types, and then we'll say abstract class HTML decorator. And the way to remember the decorator pattern and the way to remember a lot of these sort of compositional patterns, you can remember them all with like just a one-liner. For the decorator, you are going to implement and inject the interface. Implement and inject the interface. Remember that, and you'll always remember the decorator pattern. So we're going to implement, and we have this HTML element interface, and then we're also going to inject that. And so we'll say private, and we'll just call this, well, it's HTML element interface, but we'll just call it element. Okay, so now we have our API. All of the classes which extend this now know exactly what they need to do. And just by injecting elements like this, it means we're able to wrap HTML elements in other HTML elements, and that's how the decorator works. And in fact, I'm just going to make this protected. And then now we've got this in place, what we want to do is go and create an instance of the HTML decorator. And so if we go and have a look at the image which we are working with, we said at the beginning that we want to be able to wrap this in other types of HTML elements. So let's actually have a look at the scenario of wrapping this inside of a link. So inside of source, I'm going to create a class, I'm going to call it link decorator, again, letting other developers know that this is a decorator, it's part of the decorator pattern. And then what this needs to do is extend the HTML decorator. I'll just declare my strict types. Okay, so class link decorator extends HTML decorator. I'm getting the red squiggly line to telling me that I must add that h2html method. So we've added that. We'll come back to that in a moment. But first off, remember the pattern. We are implementing and injecting the interface. So here, because the HTML decorator implements that, let's go back, HTML element interface, we know that we're implementing that, but we also need to inject this to make this a true decorator. Okay, so we have our HTML element interface, but we also need to think about what is going to be custom to a link decorator. We're going to need the actual URL of the link that we're pointing to, aren't we? So let's drop down here and we'll just say private string URL, and then the link on its own would kind of look like this. So there is just a link. We're using the URL property on this, but we said that we want to wrap this around other HTML elements. So that would look like this. We can say this element, and we don't know anything about that element. We don't know what kind of element it is. All we know is that it's an instance of HTML element interface, and for that reason, that means that we can call to HTML on it, and that actual element will be responsible for rendering its own HTML. This link decorator class doesn't need to know anything about what that element is or how it actually renders. If we go back to the page where we started here, where I put in the comments about what the open-close principle is, I've got a little bit of code which I started out here just to render an image on a web page. And so we've got the source, we're passing that in to the image class, and then we're simply calling toHTML on it, and that should render an image. And so over to the browser, and this is what that is rendering. Can't click it, that is simply just an image. But we want to actually wrap that image inside of a link. So what we're going to do is going to go a little bit abstract here. We're going to change the name to element, because we don't really need to know what it is. We can create a big long chain of elements which are sort of nested inside each other. To wrap this inside of a link, we can say element equals new link decorator. It's going to want a URL from me. So there's a URL, and then we pass in the previous element in the chain, which is the image. And so we are now wrapping that image inside of a link. I shouldn't need to change any other code. I've not had to make any changes to the image class itself, but by doing this, now what we can do is go back to the browser, refresh this, and when I hover my mouse over, you see I get the little hand. If I click on that, it'll take me to the link. And so there we've gone and wrapped a image inside of a link without actually changing the image. We've stuck to the principles of open closed, which, if we remind ourselves what that says, software entities should be open for extension but closed for modification. To sort of clarify that, what we said was that once a software module is completed, and the final keyword will give you an indication that the author considers this class complete. Once a software module is completed, it should not be modified when adding new functionality. Instead, its behavior should be extended by adding new code rather than changing the existing code. So we haven't changed the existing code, and we haven't even added any code to this image class. We've been able to make it more capable. We've been able to actually turn it into a link by using the decorator pattern. And the decorator pattern is one very good way of solving the open-close problem. And by the way, if you enjoyed learning about the decorator pattern, then be sure to check out my Learn Object-Oriented PHP course, because in that course there's an entire section on design patterns. Or if you prefer a more practical approach, check out my PHP Framework Pro course, because there we'll build a PHP framework together which uses all the patterns and principles used in modern PHP frameworks. You'll really learn so much. Alright, so we're now onto the L of solid principles. L is the only one which is actually named after a person, named after a computer scientist called Barbara Liskov, and this is the Liskov substitution principle. So the thing about LSP, as we shall call it, is that the wording of it probably looks like the most complex and makes it look like the hardest to understand, but actually when you get into the actual concept of it, it's probably the easiest one to explain, or certainly the easiest one to explain without actually opening a code editor or using examples. An ironic thing about this one, like here's a little story, is that I used to work with a lead developer who, when he was interviewing people, if he decided that he didn't like the person that he was interviewing, he'd ask them Liskov substitution principle, but if he did like them, he'd ask them SRP, sort of believing that Liskov was a harder one to explain than SRP, but I think SRP is a much harder principle to explain than this one. So here we go. Let phi of x be a property provable about objects x of type T, then phi of y should be true for objects y of type S, where S is a subtype of T. Okay, so I think we're going to need an alternative explanation for this, aren't we? So this is what I've sort of come up with. We should be able to replace a class with a subclass without any unexpected behavior. I'll elaborate on that a little further. So when we say unexpected behavior, we're not saying that the program won't compile or the program won't run. What we mean is the program isn't doing what it should. We have unexpected behavior, incorrect functionality. And I'll give you an example of that in a moment. But first, let's think about the problems that LSP solves. So the problem that this tries to solve is it ensures that subclasses can be used interchangeably with their base classes without altering the functionality or the correctness of the program. So it's the functionality and the correctness which is the emphasis here, not the actual will this compile, will this run. And then just to elaborate on that a little bit further, this is where I've seen LSP breached the most, is when people use inheritance to throw in quick and dirty hacks to avoid doing a little extra work than what they'd like to do. And that's kind of the example which I'm going to use here. So imagine we have a program and it has users and you're able to log in users, and the way that you log in users is by using the user email. Now all of a sudden, like, requirements change or the program changes and it's decided that we're going to log in users with a username. So if we go and look at our user, we already have a username. We're creating the user class by instantiating it with a email and username. So what you really should do is just go and create new functionality for actually logging in the user, but that might require making change to several parts of the program and it might not be a quick and easy job. So what you'll get is some developers might think, well, I've got a quick easy fix for this, and so they'll go and come up with something like this, and this does genuinely happen. So here we've created an alt user, which is an instance of a user, except when we're saying get email, what that actually returns. So we're overriding the get email method on the base user. So if we go to the base user, we have this get email method here. We are overriding that in the alt user, and so that is then returning the username instead of the email. So it means, or technically it means, that this functionality does not have to change. But let's think about that. That is probably not the wiser strategy, is it? Because if you're using the email method to actually get a value in order to send emails, something's going to break. And just semantically, it's just not a correct thing to do, is it? When you're asking for an email, you should return an email and not a username if the username is different, if the username is not an email, which quite clearly isn't here. They are two separate things. We have an email property and a username property. Now, one of the ways which you can prevent the breach of LSP is through type safety, and that's how I'm going to do it here, by using a value object for the email. So here I've gone ahead and created this email value object. It simply holds an email and nothing else. It is immutable because value objects should be immutable. Equality is based on attributes, so if we want to compare this with another email, it will be compared exactly with the email address, and so you can do that by comparing the actual underlying values of the object. It is self-validating, and so this is partly where this will give us a little bit of safety, because when we actually create this email, we can actually check that it is a valid email when we're actually constructing the object. So here I've got an isValidEmail method, and this will actually perform a check using filter var in PHP to check that it is an actual email address. So you couldn't get away with throwing in some random username here. It has to be an email address. And there was one other point, so it can be used as an entity attribute, so we can use this email as an attribute of our user. And so you'll see here when we're actually creating the user, now the email property must be an instance of that email value object. And so when we call get email on the user, we have type hinted that as an email type to be returned. And what that means for our pesky alt user which we created is that this now breaks, because the signature needs to match the parent, so this must return a instance of email, and so if we're trying to return a username, then this is going to break. So going back to our program and this original piece of functionality here where we're logging in the user, we know that now the user email will actually be a user email. So we can't do any clever business with this. So what we'd have to do is actually go and create the correct functionality for logging in a user using the username. We can't put in a quick and dirty hack, which sort of would mask the way that the program is really working. So hopefully that was easy enough to understand. Just have a look through the code. I'll push this to GitHub and leave the repo address underneath inside the description. Just go through it in your own time. Think about how you might have solved the problem, if you can think of other alternatives, but just make sure you have a good understanding of what the LSP means, what problems it solves. And of course, if you do have any ideas on how you would solve this problem, then be sure to reach out to me in the comments and let me know how you would do that. All right, so let's go back to our original or our alternative wording of LSP, and we said that we should be able to replace a class with a subclass without any unexpected behavior, and that the problem we wanted to solve was that we need to ensure that subclasses can be used interchangeably with their base classes without altering the functionality or the correctness of the program. And so that's what we tried to do with this example. We tried to prevent a subclass from interfering with the correctness of the program. We're on to letter I of solid, and that is the interface segregation principle. And this one's not too bad. It's fairly straightforward and easy to understand as long as you have a good example. And I think I've got one which demonstrates it quite sufficiently. So let's just have a look at what the principle says, and that is no client should be forced to depend on methods it does not use. I elaborated on that a little bit further. So ISP aims to split large interfaces into smaller and more specific ones so that clients only need to know about the methods that are of interest to them. And this will make more sense when we look at the example. But what problems does this try to solve? It prevents a class from carrying unwanted dependencies and methods which it does not use. It keeps code robust and easy to maintain. And also it reduces the risk of bugs due to changes in unrelated methods affecting classes that shouldn't logically be affected. Yeah, that last one was a bit of a mouthful. Admittedly, I got that one from ChatGPT, but I kind of liked it. And so the last one that I've added here is that ISP can be quite related to single responsibility, because if you have an interface with lots and lots of methods, there's a good chance that if you were to implement those, your object would be breaking single responsibility more than if you were just implementing an interface which only had one or two methods with related functionality. So that's why I've added that one there. Okay, so here is the example. All we want to do here is take a file, so that will be source, archive it to a destination, which will be like the new file name after it has been compressed. So we're taking a file and we're archiving it simply by compressing its contents and saving to a new file location. And then the third argument for this archive file function is an instance of file operation interface, which I've called file archiver. So file archiver describes what we are trying to do here, doesn't it? However, this name file operation interface, these kind of names should be a bit of a red flag because you want your service classes to, or your service class interfaces to have names which describe what they do. So if you see a sort of vague sounding name here, there's a good chance it's asking you to do lots of things. And if we go and have a look at this, then we can see it's asking us to do lots of things. So here we have all these methods which are related to operations which you can perform on a file. However, we only want to archive the file. Both these actions here are related to that one single action or one single responsibility of archiving the file. However, if we want to go and create a file archiver object that implements this, it means we also need to implement all of these methods. So that's pretty painful, and it's something which we want to avoid. And if we go back to the additional sort of description which I added here, we said that ISP aims to split large interfaces into smaller and more specific ones so that clients only need to know about the methods that are of interest to them. And the only methods which are of interest to us here are read and compress. Okay, so we're going to take this as the starting point for our solution. We're going to split the interface into smaller, more specific ones. And the best way to do that will be according to the problem which you are trying to solve. In our case, what we want to do is archive a file, and we only need two of these methods in order to do that. That will be read and also compress. So what we're going to do here is create a smaller interface which contains only those methods, and we're going to name it appropriately. We'll call this File Archiver Interface. And so I've worked ahead, and this is what I've come up with. File Archiver Interface. I think you'll agree this is much better, be much easier for a client to use and to implement, and it's much more focused on the task in hand, which is just reading a file, grabbing the contents and compressing it to another destination. Back in the client code, here is the archive file function, and you'll notice now that I've updated the signature so that the third parameter is the file archiver interface, and you'll notice that there's more of a closeness between the name of the object and the interface. Now this is no longer vague, and we've got a good description of what this will do. It's to the point and there's no ambiguity. So I also created a file archiver which implements that interface. So we have the two methods on here. Read. Don't really need to know much about the details, but we'll demo this in a second. And then compress. Okay, so for completeness, let's have a demo. I've created, or I've instantiated, a file archiver. We're calling the archive file function. We're passing in example text, example txt. So I've created that file here in the same folder as the one where this code is. And then we're saying we want to compress this to this file location here, example.txt.gz, and then we're also passing in the file archiver, which is the third parameter for the archive file method. So if we go and run this, we get the success message here, which I added to the archive file function, and you'll see that we get the example.txt compressed file in the sidebar there. Let's return to the definition and check some things off. So no client should be forced to depend on methods it does not use. So now we've updated our clients to depend on only the methods which he's going to use. And we split the large interface into smaller, more specific ones which were specific to the task which we wanted to achieve. What problems does this solve? Prevents a class carrying unwanted dependencies and methods which it does not use. Check. Keeps code robust and easy to maintain. Goes without saying that code will be more robust and easy to maintain if it only contains two methods rather than 10 methods to perform simple tasks. And then we reduce the risk of bugs due to changes in unrelated methods. So there would have been lots of unrelated methods which we would have had to implement in all of the classes which were sort of implementing that object, which was, I forget the name of it now, our file operation interface. Like I say, all those methods on there gives you a higher chance of bringing bugs into your code. And then we said we're more likely to adhere to single responsibility. And the methods which we used on this file archiver interface were all related to the responsibility of the actual object, the file archiver, and so we've adhered to single responsibility there, which would have been very hard using that original interface which we looked at to achieve this simple task. So I think overall there we've come up with a nice solution, and we've avoided having to use this interface here, which has been a clear breach of ISP. We've made it to the end. We're now on the D of solid, the dependency inversion principle. I think this one, I put it sort of alongside single responsibility principle in that the wording makes it more confusing than what it actually is, or than what the problem solves. There's a few parts of the wording which sort of need to be translated, I think, in order for it to make sense. But we'll have a look at the wording now. And the main things when I say the wording are stuff like high-level modules, low-level modules, inversion. It all makes it all very sort of highbrow computer sciencey and more complex than what it actually is. So high-level modules should not depend on low-level modules. Both should depend on abstractions, for example, interfaces. So I think we understand abstractions and interfaces, but we're going to cover it in this one anyway. And then it says that abstractions should not depend on details. Details should depend upon abstractions. Now, before we go any further, let's take care of that terminology there. So we've just mentioned high-level modules and low-level modules, and it's not really going to make much sense to go any further without really having a good grasp of what we're talking about there. So high-level modules, think of these as your code or your classes which take care of the business logic, the core functionality. In our case, the example we're going to use is we're going to have an order processor for processing an order, like an e-commerce order or something like that. That is the functionality, that is the task that we're trying to achieve. So we can think of that as a high-level module. But in order to complete that full task of processing an order, there might be other things that needs to happen. We might need to email a customer, we might need to log something to a log, we might need to write data to the database. And so we can think of the components that handle those tasks that we are depending on as the low-level modules. So in our case here, what we're going to have is we're going to have a logger component. That is our low-level module, the one that takes care of the smaller bit tasks which are part of the overall high-level task. One way to think about it is the high-level code is concerned with what gets done, whereas the low-level code is concerned with how it gets done. Okay, so with that explanation out of the way, let's go on and have a look at what problem is solved by dependency inversion. So the dependency inversion principle addresses a problem of tightly coupled code, which often occurs when high-level modules are directly dependent on low-level modules. And this tight coupling leads to difficulty in modifying, and also, well, let's complete that, changes in the low-level module can affect the high-level module, and also challenges in testing where high-level modules are harder to test in isolation because they are directly dependent on the details of low-level modules. And you'll see an example of that when we actually go on and run some tests which is related to our order processing. Now, this is the order processor that I was talking about. It has one private property, which is a logger. We have a constructor, and you'll notice that in the constructor, I am instantiating an instance of file logger, and then that is what we are using to log something when an order is processed. So the problem we have here is the tight coupling. This order processor is directly dependent on the file logger simply because it's been instantiated inside of the class. So if we wanted to perform our logging in a different way with a database logger, I have a database logger here which behaves slightly different. If we wanted to log to a database instead, well, we're kind of stuck, aren't we? Because we've created this hard coding here and we've created this direct dependency. There's nothing loose about this design whatsoever. This order processor will only ever be able to log one way because it is dependent on a concrete implementation. Whereas if we look at the wording of dependency inversion, high-level modules should not depend on low-level modules. Both should depend on abstractions. We're not depending on an abstraction. We are depending currently on a concrete implementation. And also when we run our tests, we cannot bypass this, and it means that we're always going to write to a file when we run our tests. Let me give you a demonstration of that. So inside of tests, I've created this order processor test. As you can see here, we instantiate an order processor, just creating some test data, and then we're going to process that order and just assert that the result is true. So just a little bit of make-believe here. All we're doing here is taking the order data and I'm just setting a key on there, order processed to true, and that is what we're testing against. But the thing I'd like you to notice here is that when I run this, then this part here is going to happen. We are calling log, and that is going to log something to a file called log.txt. So if I run vendor bin php unit tests, the test runs, everything passes. However, look what's appeared in my project here. I've now created this log.txt file, and I shouldn't really have to go and create files every time I run the tests. I should be able to swap this for a double, but it's impossible to swap it for a double because I've instantiated it inside the class and created that concrete dependency. And this is just one example of where it becomes complicated in tests. But can you imagine if we were connecting with a third-party service over the web, or if we're writing to a database or retrieving data from somewhere else, writing data to somewhere else. It means you will be dependent on all that technology working on having those connections just to run a test, simply because you created a concrete dependency. Whereas now what we're going to do is we're going to switch this out for an abstraction, and that means I'll be able to provide a double for the logger, and by doing that it means we won't actually get the logger to do anything, because it will just be stubbed, and what will happen is we'll just test the functionality that we want to test, that the order is being processed and that we're getting the correct result back without actually having to touch that dependency. Okay, so I'm going to go and delete that log.txt file, and I'm going to switch to the branch with a solution on it. Okay, and this is the change I have made. So, high-level modules should not depend on low-level modules, they should depend on abstractions. And this is what I've created here. By injecting a logger interface, it means we have a much more flexible design. We're not dependent on a concrete implementation, and anything which implements logger interface can actually be used in our order processor. And so if we look at our options here, I have a file logger which implements a logger interface, and this logs to a file. I also have a database logger which implements logger interface, and instead this writes to a database. And so this is a much more flexible solution. If we return to our order processor test now, you'll see, because we made that change where we are now injecting a logger interface, we are injecting the dependency, and that dependency is an abstraction. What we can do is we can create a mock of that abstraction. So the logger interface is now being mocked, and that also means that we're not really going to be calling a log method on our logger when we run this test. Because we are using that mock, all we need to do is just set an expectation that the log method is being called the correct number of times, and that it is being called with the correct data. But we're not touching the insides of any log method, because the logger interface doesn't have any detail in a log method. It just provides the API for us, just the interface. So we're avoiding the problem of this being harder to test in isolation, because we're no longer dependent on the details of the low-level module. Let's actually run this. So vendor bin PHP unit, we'll run that. The test passed last time, so there's no change there. There is one extra assertion, and that is because here we are checking that the method is being called and with the correct detail. If we go and look at the project files, you'll see nowhere here has a log.txt method being called. So we're completely avoiding doing any unnecessary low-level stuff during our testing. By the way, if you want to learn more about testing and how to test any kind of code, just check out my PHP testing bundle. It contains everything you'll ever need to know. So just going back to the wording, high-level modules should not depend on low-level modules. Both should depend on abstractions. So our order processor is dependent upon an abstraction, and that is a logger interface which is being injected. But also the actual low-level modules are dependent on the logger interface. If we look at our file logger, that implements logger interface. If we look at our database logger, that implements logger interface. So both the high level and low level modules are dependent on that logger interface. What else? Abstractions should not depend on details. Details should depend on abstractions. And so that's sort of what we've just covered there. The concrete implementations are dependent upon that abstraction, that logger interface. So did we solve the problem that we set out to solve? The dependency inversion principle addresses a problem of tightly coupled code, which often occurs when high-level modules are directly dependent on low-level modules. So when we were instantiating that file logger inside of the constructor here, we were directly dependent upon that low-level module. But now we are no longer directly dependent on any low-level module. We are just dependent on that abstraction. And so that tight coupling leads to difficulty in modifying. Changes in low-level code can affect the high-level module, and also the challenges in testing. High-level modules are harder to test in isolation because they are directly dependent on the details of low-level modules. And we sidestepped that problem by actually being able to mock the logger interface, which we were only able to do because it was being injected through the constructor. And so that's the dependency inversion principle. Once again, the code will be pushed to GitHub, where you can look at the start of the principle and also the solution. I created 2 branches for each. And the things to understand really are get a good understanding of what low-level modules are, what high-level modules are, and what is being inverted. That's always another part of the wording which used to confuse me. Basically what we're doing is we're changing the dependency, we're shifting the dependency to an abstraction rather than a concrete implementation. So sometimes I think rather than refer to it as something being inverted, which can kind of confuse my mind, is we're just shifting the dependency to something else. And so that brings us to the end. I hope you've got value from the things that I've shown you over these previous 5 recordings. It's actually been a lot of fun for me to do like the discovery, look at alternative wordings for these principles, to come up with solutions, to come up with preventions, and to also explore the problem that these principles intend to prevent and solve. And so if you want any of the material, the GitHub links or any of the courses which sort of include stuff like object-oriented programming, design patterns, I'll leave all those links under the video. Thanks for watching, and until next time, have a good one.